Hey, Science Nines, and welcome to our final discussion for Space Exploration Unit, and in fact, our final discussion in video for Science 9. This is the end. So, today I'm going to walk through topics 4.1, 4.2, and 4.3 in the textbook, and they are basically related to the effects of space exploration on society and the environment. A pretty small section of the textbook, but there are some interesting questions that are sort of posed by humanity's quest to enter space and explore new regions of the universe. Some of the problems that we have here on Earth, we are maybe bringing with us into space and into perhaps new worlds if we decide to eventually colonize places like the moon, maybe eventually Mars, and even beyond that in future decades and centuries. So, first of all, space is a dangerous place. We've been pretty much sending people into space for just over 50 years now. We started sending people in the early 60s when Yuri Gagarin was the first human to enter space, which basically started the human space race back then. But a quick question for you: in all the years of space exploration, humans have now been in space for over 50 years. How many people have actually died in space? Great, well, not a great question, but I guess a very important question to ask. With all the people that have gone into orbit around the planet, how many people have actually died in space? So maybe give that a thought. And I'm going to give you the answer here in a couple seconds, but I would suggest you watch this video because this video is going to take a very good look at all the catastrophes that have happened in the history of space travel, and there have been a few of them. But before you watch that and before I have my say, maybe take a guess in your head: how many people do you think have actually died thus far in space? Um, Again, if you've watched that video now, I will spill the beans. Pause me if you don't want to know the answer before you watch the video. Um, Really, there have only been technically, if you look at space as by definition, there have only been three people that have actually died in space. There have been many astronauts that have lost their lives either on the ground, uh, in either ascending out of Earth's atmosphere or descending back into Earth's atmosphere. But only three astronauts, they were actually cosmonauts, that actually died in actual space. You may be familiar with some of the more recent tragedies in space travel. The 86 Challenger disaster, the Space Shuttle Challenger, which blew up as it was lifting off from Cape Kennedy in Florida, and the Columbia, which basically disintegrated on reentry into the Earth's atmosphere in 2003. There were some issues with the heat shields that basically um, caused the actual the module to actually break up as it came back into the Earth's atmosphere. But in both cases, these were astronauts that died inside the Earth's atmosphere. But regardless of where these astronauts are dying, it just kind of shows that this is a very dangerous, I guess, area of exploration that we're dealing with in space. I mean, humans are not designed to live in space, and the technology we take that takes humans into space are basically designed to keep us safe while we're there. They don't always do that. So there are obviously very inherent risks with space travel when you're dealing with humans, and that's why a lot of space agencies have gone to unmanned space probes to explore areas. That way, humans and some of it is logistics because of just the great distances and time that it would take to explore planets in the outer solar system. But we send probes to Mars rather than maybe sending people there. But now there's talk of people sending people to Mars, right? Sending people to set up a lunar base. This will involve getting people back into space again beyond the International Space Station, and that safety aspect has to be looked at with any future space, manned space or woman spaced exploration. Another thing for astronauts that they have to watch out for when they're actually outside of the Earth's atmosphere, they have to watch out for cosmic radiation. We talked, I briefly mentioned this, that the Earth does generate a magnetic shield. The Earth's the spinning of the Earth creates electrical charges inside the Earth, and we know that electrical fields now generate magnetic fields. So we have a magnetic field that surrounds the Earth, and that protects us from some of the more harmful cosmic rays, the more dangerous electromagnetic radiations or energies that are released by the sun X-rays, gamma rays, some of the high-end UV rays, which I also discussed in this course, we're being protected from on Earth by things like the ozone layer. But once you leave the Earth, humans are bombarded with this cosmic radiation a lot more than they are on Earth, and there is problems with this, and perhaps increased risk of cancer, of other diseases that are caused, like increased aging, of spending time out in space. And there's been a lot of studies that have been done on this. In fact, one of the more interesting studies that was done a few years back was there was an astronaut who had a twin brother on Earth, and they actually monitored the two brothers before he went into space on the International Space Station. He then completed a several-month mission on the International Space Station, and then they compared the DNA of both the twins after he came back to Earth, and there were noticeable differences to his DNA compared to his brother who had not left the planet. So it was sort of an interesting take on, kind of using a genetically identical twin to kind of chart the progress and the destructiveness of space, even on human DNA. So these are things, again, that have to be looked at with prolonged exploration into space. If people are going to live, let's say, on the moon for extended periods of time, or going to live, set up a colony on Mars, these would all be things that we're going to have to deal with to protect. We would have to almost create like an artificial magnetic shield around some of these colonies to perhaps help to negate some of the effects of these cosmic rays that people in space are being affected by outside of the Earth's atmosphere. Another issue with the humans' presence in space is space junk. Anytime we launch satellites that don't, and then when those satellites eventually fail or break down, they're basically spinning around the Earth. We're basically creating a layer of debris around the Earth. Discarded rockets, satellites, all sorts of debris that are in space. And this is going to make it tougher to sort of clearly, safely exit the Earth's atmosphere if we continue to basically leave that stuff up there rather than actually cleaning it up. So again, you wouldn't necessarily think of garbage or litter in space, but there is in fact a term for that, and it's called space junk, which is a concern, because obviously the more of these satellites we put into orbit, the more of them are going to eventually break down, and then that causes more and more of these vehicles to basically be left up in the orbit, which can cause issues for exit and re-entry into the Earth's atmosphere. All right, let's go on to 4.2, a little bit more positive stuff. Canadians have been leaders and innovators in space exploration for decades. We don't necessarily maybe think of that as Canadians, but I mean, Americans and the Soviets, or the Russians are sort of the big ones that are sort of at the forefront of space exploration, the Chinese. But the Canadians have had a good little say in space exploration. Give you a couple of examples of where Canadians have sort of done right in the world of space exploration. The first physical evidence of a black hole was discovered in Canada in 1972 in the University of Toronto. They found the first black hole in Cygnus X1. And guess what, folks? Just like I talked about earlier in the unit, they used triangulation and they used parallax to discover how far away that black hole was, in fact, how big it was. They used that method that I discussed in the last, I think it was the last video. It was the last video. Yes, it was 3.3 where I discussed that. So they used that method to basically calculate the distance of the black hole in Cygnus X1. The Canadarm, if you remember back that far, if you've seen images, there was a big arm that was on the space shuttles back in the day, and they used them from 1981 to 2011 with the space shuttle missions. Used on 90 of those missions. 90 missions used the Canadarm to retrieve or release payloads from the back of the space shuttle. It allowed all sorts of stuff to happen. And Canadarm2 now has been a permanent fixture on the ISS, the International Space Station, and it's been up there since 2001. There's only been a few Canadians that have ever been in space, even though we've had a lot of leadership in space technologies and stuff like that. We haven't had a lot of Canadians that have actually been in space. The first Canadian who was in space was a guy by the name of Marc Garneau, who's now currently an MP in Ottawa. He's serving as a Liberal MP in Ottawa. He was there in 1984. The first Canadian female was in 1992. That was Roberta Bondar, who was launched into space on a space shuttle mission. became the first Canadian female. Chris Hadfield is probably the most famous Canadian astronaut to the generation now. He was the first Canadian to do a spacewalk in 2001, and he then proceeded to spend 5 months on the International Space Station from 2012 to 2013. You've probably seen footage of him. He's been very active since he's been back from space. You might remember the footage of him playing David Bowie, playing some acoustic guitar up in space, playing a little space oddity up in the International Space Station, ground control to Major Tom. If you Google that, Google Space Oddity, Chris Hadfield, I'm sure it'll be on YouTube somewhere for you to watch. And a couple more. University of Guelph over in Ontario leads the world in building greenhouses in space using the technology of hydroponics, which is right there. Growing food in very small locations without soil. They're testing small hydroponic crops of lettuce, radishes, tomatoes, cucumbers in Nunavut. They're actually using Nunavut because it has very little sunlight, seeing if they can grow these crops up in the extreme far north of the country. If they can grow them there, why not couldn't we grow them in a spacecraft or on a space colony on the moon or in a space colony on Mars, right? We'd be able to grow food on our own. And again, earlier in the unit I mentioned that if you're interested in some of these technologies about the Mars colony, I still really strongly encourage you, if you haven't already, watch the Matt Damon movie The Martian. There are obviously some issues with the science behind it, but overall not a bad little movie discussing the technologies that are related to having a space colony or even a space outpost on a distant location like Mars. And finally, there are even some locations in space that are named after Canada. We have little bits of Canada on Mars. Several of the craters on Mars, a lot of the craters on Mars actually, are named after Canadian places. So if you go to Mars, there is a crater named Banff. There is a crater named Okotoks. There is a crater named Penticton, Inuvik, Gander. These are just to name a few, but there's quite a few Canadian place names on craters on Mars. So even that is kind of cool that we have. There isn't just Banff, Alberta. There's Banff, Mars as well, just in case you ever wanted to visit Banff, Mars. Now you have your chance to do so. I have a feeling the scenery in Banff, Alberta might be a little bit more scenic, but heck, going to Mars would be pretty cool, I would think. And finally, before we conclude everything here today, what are some of the issues related to space exploration that I haven't already discussed? Are there some political issues? Are there ethical issues? Are there more environmental issues? Well, yeah, there are. A couple of questions to keep in mind here. Who owns space? Good question. Just because the Americans are sending astronauts into space, does it mean the Americans own space? Doesn't everyone own space? Is there ownership of space? How do you put a price tag on a piece of space? How do you put a price tag on a piece of the moon? A good analogy of this would be the Antarctic. The Antarctic is a continent that's owned by no one. It has basically been an open continent for scientific research. There's been treaties that have been signed by countries around the world that no country is trying to claim territorial or mining rights or mineral rights in the Antarctic. That would be something that we would want to consider if we move into space. Like just because, we plant the flag on the moon, does that mean that we own the moon, right? I mean, there are some questions there for sure. And again, who gets the right to mine the resources in space? If we, decide to mine a comet or mine an asteroid or something in space that we want to extract mineral resources from, should we be able to do that? Who has the right to do that? Who will determine how space will be used, right? Are we going to use it strictly for scientific purposes, or are we going to go out there and we're going to wage war on each other, right? Like Donald Trump's Space Force, we're moving in that direction. It's kind of a scary one, but again, these are things that have to be considered before we get up there, because otherwise it's going to be like the Wild West if we don't have rules in place before more and more people get into space. Who owns the International Space Station, right? Who has access to it, right? Right now, who has access to it? It's the people who can catch a lift on a rocket in essentially the Russia. Russia is setting the rockets up to get people to the International Space Station right now. So there is a bit of control of who can enter space. Should space be available to everybody, not just to the countries that have access to rockets that can send people into space? What are some of the ethical issues? Well, is it right to spend money on space exploration when we've got people starving here on Earth? right? I mean, space exploration costs a lot of money. A lot of budgets and a lot of countries are dedicated to space exploration. Should we be worrying about that if we can't feed our own people on our own planet? Definitely something to consider. Do we have the right to materials in space to meet our needs? Should we be even going into space to get materials? Like, is this something we should even be considering? How should we ensure that space exploration benefits all humanity and not just a few nations that are actually doing it? Should we, so far the information that's being collected by, things like the Hubble Space Telescope are not just being kept secretively by the Americans. They're sharing that information with the world when these scientific discoveries are being made. And should that not be the case for all discoveries made in space? I would say yes, but could that change in the future? We don't know. Environmental issues, a couple more. Who's responsible for protecting the environment in space, right? People that are going up there, people who are putting up those satellites, should they not be cleaning them up when they basically become defunct? Should they be making some ways to get these satellites, to get them safely, maybe to burn up in the Earth's atmosphere, to get them out of the orbit so that they're not causing that problem with space junk? And again, who is responsible for cleaning up that space junk? And should there be, protective forces up there? We got the sea, we got the Space Force. There it is again, right? I mean, we got the Air Force, we got the Navy, we got the Coast Guard. If we're going to spend more and more time in space, should there be a protective service up there to protect people if they're up there, right? It's kind of, there's some interesting questions, and that will become more and more issue as people move further and further into space and more people go into space. That's it. The course is done. Congratulations. This is the end of Science 9. It's the end of the space unit. I got one last set of questions for you before we move into your review for the exam, the PAT exam, and your in-class final. Complete questions 1 to 7 on page 469 of the textbook, and then we'll discuss those in class, and that's it. Thanks a lot for tuning in. Hopefully you've learned something here in Science 9 this year. I hope you did. It's been my pleasure to present these videos to you and present the course to you, and I hope to see you very soon in one of my other science courses at the grade 10, 11, or 12 level. Thanks a lot for tuning in, and have yourselves a good one.